Look up at the night sky. On a clear evening, you might see a blanket of stars, the shimmering dust of the Milky Way, maybe a planet or two. It feels infinite, doesn't it? But what if I told you that everything you can see, stars, planets, gas clouds, galaxies, makes up only about 5% of the entire universe? That means 95% is invisible, unseen, and unexplained. It's a profound and almost unsettling idea, but it's one that science has been grappling with for nearly a century. The majority of the universe is composed of two mysterious entities, dark matter and dark energy. Of the two, dark matter has fascinated scientists and philosophers alike because it doesn't just sit out there quietly. It shapes galaxies. It holds cosmic structures together. It's the scaffolding upon which the universe is built. But what is it? And could it hold the key to understanding not just what the universe is made of, but whether we're truly alone in it? In 1933, Swiss astrophysicist Fritz Zwicky observed something strange while studying the Coma Cluster, a massive collection of galaxies. The galaxies were orbiting the cluster's center at speeds that shouldn't have been possible based on the visible mass. According to Newton's laws, they should have flown apart, but they didn't. Zwicky proposed that there must be some unseen matter, something invisible but massive, holding everything together. He called it Dunkle Materie, or dark matter. At the time, few took him seriously, but he had stumbled onto something profound. Fast forward to the 1970s. Vera Rubin, a pioneering astrophysicist, was studying the rotation of spiral galaxies. According to classical mechanics, stars farther from the center of a galaxy should rotate more slowly than those near the core. But Rubin's observations showed otherwise. The stars in the outer arms of galaxies were moving at speeds nearly identical to those closer in, as if something unseen was exerting gravitational force across the galaxy. That something was dark matter. Rubin's work provided the most compelling observational evidence yet. Zwicky had been right. That's the billion-dollar question. We know what it isn't. It's not composed of atoms or any form of matter that emits, reflects, or absorbs light. It doesn't interact with electromagnetic forces, which is why we can't see it or touch it. It's completely invisible, and yet it exerts gravitational influence. That narrows down the suspects to a few theoretical candidates. One is the WIMP, or weakly interacting massive particle, a hypothetical particle that is heavy, stable, and barely interacts with normal matter. Another possibility is the axion, an incredibly light and ghostly particle predicted by quantum theory. Others suggest the existence of sterile neutrinos, a variant of neutrinos that interact only through gravity. We've built massive underground detectors, from Xenon T in Italy to Lux Zeppelin in the US, designed to catch the tiniest interaction between these invisible particles and atomic nuclei. But so far, these detectors have heard nothing but silence. That doesn't mean dark matter isn't real. It just means it's more elusive than we ever imagined. Even if we can't directly detect it, we can observe what dark matter does. It's like the wind, invisible, but we can see its influence. One of the clearest signs is in how galaxies behave. They're embedded in dark halos, enormous spherical regions filled with dark matter that keep them intact. Without dark matter, galaxies as we know them couldn't exist. Another piece of evidence comes from something called gravitational lensing. According to Einstein's theory of general relativity, mass bends space. When light from a distant galaxy passes near a massive object, like a cluster full of dark matter, the light bends. We've observed countless examples of this lensing effect. Often, the amount of visible mass can't explain the degree of lensing we see. But when we factor in dark matter, everything suddenly makes sense. It's like seeing shadows from an object you can't see, but knowing with certainty that the object is there. Zooming out even further, we find that dark matter shapes the universe on the largest scales imaginable. Simulations of the cosmos, based on known physics and cosmological data, show that galaxies and galaxy clusters form along massive, thread-like structures known as the cosmic web. These filaments stretch across billions of light years. And what forms this web? Not visible matter, but dark matter. It's the backbone of the universe. The cosmic web is how matter clumped together in the aftermath of the Big Bang. Without dark matter, the early universe would have expanded too uniformly, and structures like stars, planets, or even life wouldn't exist? What if dark matter isn't just passive? What if it has its own forces, its own physics, even its own complexity? Could dark matter clump into objects? Could it form stars, planets, life? While this may sound like science fiction, some physicists have proposed the existence of dark stars, massive objects powered not by fusion but by the annihilation of dark matter particles. And if dark matter interacts with itself, even weakly, could it evolve into something more? A dark biosphere, maybe even intelligent civilizations made of this invisible stuff. Now imagine this: there could be an entire shadow civilization made of dark matter existing within our own galaxy. We wouldn't be able to see it, touch it, or communicate with it, and they wouldn't see us. We'd pass right through each other like ghosts. If dark matter is the dominant form of matter in the universe, and we are the outliers, then perhaps we're the invisible ones. In a strange twist, maybe the universe is full of life. We just don't know how to look for most of it. This idea brings us back to the Fermi Paradox, which asks, if intelligent life is common, then where is everybody? We've scanned the skies for decades, listened for radio signals, searched for megastructures around stars, and found nothing. But maybe that's because we've only been looking in the visible spectrum within the electromagnetic universe. What if intelligent life evolved not from atomic matter, but from dark matter? What if we've been surrounded by civilizations for billions of years, civilizations that don't know we exist, because to them, we're the invisible ones? The implications are mind-boggling. It would mean that we're not alone, not even rare, but simply limited by our biological senses and the narrow tools we've developed so far. There could be layers of reality intertwined with our own, governed by different physics, shaped by forces we have yet to discover. If we could unlock the secrets of the dark sector, it might be the greatest leap in science since the invention of the telescope. We must remember that dark matter isn't the only unseen force out there. There's also dark energy, a force even more mysterious, responsible for the accelerating expansion of the universe. While dark matter pulls things together, dark energy pushes them apart. It makes up 68% of the universe, leaving just 27% for dark matter and 5% for everything else. Together, they form the invisible framework of reality. We live in a universe where 95% of what exists is unknown, a universe where light is the exception, not the rule. So, are we alone? It depends on how you define alone. If we mean alone as in the only intelligent beings in the universe, then probably not. The odds are against it. But if we mean alone in the visible universe, that might be closer to the truth for now, because we're starting to realize that the universe is not only stranger than we imagined, but stranger than we can imagine. Dark matter is more than a scientific curiosity. It's a gateway to a hidden reality, a realm where the rules may be completely different, where life, structure, and intelligence could emerge in forms we've never considered. We may be standing on the shore of a vast, invisible ocean, unaware of the civilizations sailing right past us. The darkness is not empty. It's full, and it's waiting.